So 4-56 says Jamie ran 9.3 miles in 1.5 hours, or excuse me. Jamie ran 9 3/10 miles in 1 5/10 hours, or 1.5 hours. How far can she run in a given amount of time if she runs at a constant rate? So we need to represent the situation with a graph. Now, the hard time that I have with this particular problem, I'll be honest, is that that's kind of a difficult thing to do without having a table. I always make my graphs from a table, but we're going to make it happen. Here we go. So we know for sure, and I'm going to write it right here, that 9.3 miles in 1.5 hours. I'm getting tired. I'm not saying the decimal right. Good gravy. So we need to, first of all, I'm gonna go ahead and we're gonna put some intervals on both our X and Y axes so that we can make sure that we can see everything. We want that information to be that way. So for my time in hours, this is only 1.5. So I'm okay with going by ones here. So I have 1 hour, 2 hours, 3 hours, 4, 5, and 6. Hopefully that poor girl isn't running for more than 6 hours. Over here on this side, because we have 9 3/10 miles right here, I'm going to do this one not by ones, because otherwise I'm not going to be able to put more than 1 point on there. So for this one right here, I'm going to call this one, let's call that 2. Let's do it by 2s. 2, 4, 6. Hopefully you can see that. I know sometimes my hand gets in the way. 8, 10, 12, 14, 16, 18, 20, 22. Because I want to at least I like to have at least 3 points on a graph so that I can make sure that I didn't make a mistake on any of them. So that's kind of what I try to do. So I know for sure I can go over to 1.5 on my X axis, 1.5 hours, and then find about where 9 3/10 miles is. It's going to be right there about the middle. And I usually make them when I hand do graphs. I make my dot a little big to help me out a little bit, so that if I mess up, it's not as bad per se if I'm off a little bit. Now what I could do is I could always double these. So if I have 1.5, that would now become 3 hours. And then I would double this right here too, and I get 18 6/10 miles, which I can fit on the graph. So now I'm at 3 right here. And then we're going to find, should be about a little more than 18, but not much more. And of course, if Jamie can't find her tennis shoes, her dog ate them. She can't run today. How long did it take her to run? Nowhere. 0 hours. So we have 0, 0 because it takes her no time to run nowhere. Right here. So I'm going to take my ruler, and if I did it right, they should line up. But again, this is a spot where I do the bigger dots. I plot a bigger point so that it's not as obvious if I'm a little off. If I have something up here, then I made a mistake, and that's why I like to have at least 3. Okay, so that's our graph. Bravo says, what's the constant of proportionality? How can we find it on the graph? So we are right here. So to find the constant of proportionality unit rate, I'm going to come over here to my 1 on my x-axis, my unit. And then depending upon how great I am at doing my graph here, hope you can still see this, but I'm just trying to kind of line it up for about where it's going to be. And it's going to be about here-ish. So I have it about here-ish, and then I come across, and it looks like to me it's about 6 miles per hour. So how I found that was I went to 1 on the x-axis. I went up to the line. And put a dot. Kind of, sort of. Then I went over to the x or y-axis. Whoa. That would be the y-axis. Which that would be your unit rate or constant of proportionality. So how can I use a graph to determine if a relationship is proportional? So I still have my same 2 rules. So on a wow, that looks wrong. I'm struggling with that right now. Oh, I'm not even on the page. Proportional. Let's just start over again. Getting later. My snack's running out. Okay. Proportional. Oh, that looks better. Graph. It starts at the origin, which is at 0, 0. Remember, this is if x is 0, y is 0. It also has a straight line. And that's how I see the constant multiplier. Now, for this one here, I'm going to go ahead and stop, and we're going to go back and we're going to divide to find the true constant of proportionality or unit rate, because again, we know that on the graph, it's not very accurate. And so what I'm going to do is I'm going to take this part that was in our original, which was, actually I'm going to take this guy right here because I want a whole number for my divisor. So I'm going to take 18 6/10 miles, and I'm going to divide it by the 3 hours. And that's going to give me how far she can run in 1 hour precisely. So I'm going to start right here. So I have 18 divided by 3, which is 6. I'm going to make sure my decimal's there. 6 times 3 is 18. 0 leftovers. I'm going to bring this guy down. How many 3s are in 6? That would be 2. 2 times 3 is 6 with 0 left over. So my real constant of proportionality, which I was close to, is 6.2 miles per hour. So for 1 hour. I'm going to go ahead and do that because you're going to need it later.